Hi everyone, welcome back. This is part 2 of the atom. So in this lesson, we want to find out what is the atom and how do we make diagrams of it. And our learning objective for today is to be able to make a diagram of an atom, especially just given the information that we have on the periodic table. If you haven't set up your notes yet, take a moment. You can use this one or you can open the file in the link above and set up your notes for today so you can fill them out as you are watching. So just so you know, there are definitions at the top, and we're going to be drawing this periodic table tile, and we're going to be working on potassium today. So your first definition is, what is an element symbol? We talked about this last week, but we really want to define it so that we're using them correctly. An element symbol is one or two letters that represent the name of an element. All right, and so some of these symbols look like the word they represent. So for example, nickel, its symbol is Ni. But there are other elements that don't look like the word they represent. And an example might be iron. So iron is Fe, even though there's no F in the word iron. And whenever you see ones that don't match up, it usually comes from the Greek words for those elements. They're usually the elements that we knew about a long, long time ago. All right, and so that was from ferrous. Also, the first letter is always capitalized. We're going to talk about that in the next one when we are looking at patterns. All right, so if we see the periodic table down here, we can try to find the symbols for these words. Hydrogen is right here. The element symbol is H, capital H. Try to find helium. That's over here. We looked at helium as an example. We looked at its atomic number last week. Its symbol is capital H, lowercase e. Carbon, we looked at this at our synchronous meeting last week. It's right here. And its symbol is simply a capital letter C. Sodium, on the other hand, is right here, and its symbol is capital N, lowercase a. That stands for natrium, and that's an old word for sodium. And then iron, which we just talked about, which is capital F, lowercase e. Okay, so you don't have to write down any of these examples, all right? That's just showing you where those symbols are coming from, and you can see the name on the periodic table. But we do want to include these two patterns. So the first pattern is that the symbols are always one or two letters. And the second pattern is the first letter is always capitalized. All right, that means if there's only one letter, it has to be capitalized. Take a moment and leave a little bit of space because we have two more definitions, but we're going to draw the periodic table tile for potassium in our notes because we're going to show how we get some information off of it. All right, so here's the things that the periodic table tile can tell us. It gives us the element name. And so let's label our tile. This is the element name. It also gives us the element symbol. It also gives us this number we talked about last week, the atomic number, which is our number of protons. And also, if you were there for a synchronous meet, we talked more about this, that a neutral atom has the same number of protons and electrons, right? That's what makes it neutral. And then finally, we have this number down here, and we haven't talked about that number yet. So We're going to take a look at that right now. This number is called the atomic weight. All right, so what is the atomic weight? We haven't talked about it. It is the average mass of an element. And so why are we taking average mass? Well, that comes from all of those things called isotopes. Remember, some atoms weigh more than others. And so we average out the mass. And you'll see that we have kind of a decimal value here because of that average. All right, and then we have this other thing called the atomic mass number. And so one of the biggest differences here, this word number, it implies that the atomic mass number has to be a whole number. That means no decimal value. It's the total number of protons and neutrons in the nucleus of an atom. And we can be more specific than this. Now that we know about isotopes, it's the total number of protons and neutrons in the nucleus of the most common isotope of an atom. Okay, so you'll notice, and when we say, remember the protons and the neutrons are the particles that carry all the mass of the atom, right? So this atomic mass number is the sum. It's the sum of the protons and neutrons. So you could make an equation that looks like this. Number of protons, add that to the number of neutrons, and you get the atomic mass number. All right? Okay, so to find the atomic mass number off of the periodic table tile, we're just going to round it to a whole number. So 39.098. When you say we're going to round this to a whole number, it means we don't want any decimal values, right? We just want a whole number. And that means if this number is 5 or more, we round this number up. Okay, but this is a 0, so this should be easy one to round. This just rounds to 39. And then we have this thing called AMUs. That's not super important right now, but it's the unit of mass of an atom. It stands for atomic mass units, and really it's talking about protons and neutrons because those are the mass units of the atom. All right, so going back to our periodic table tile, that's in your notes, make sure you label this number now as the atomic weight, and then you can round it to 39 and label this number the atomic mass number. Okay? All right, so let's find out how many protons, neutrons, and electrons are in potassium. So we know that the atomic number tells us the number of protons, and we know that in a neutral atom, the number of protons has to equal, oh, I got those orders mixed up, has to equal the number of electrons, so we're going to put that down here, okay? And then we're going to use the mass number to find our number of neutrons. Okay, so remember that equation we wrote before, and I'm just going to put my work at the bottom here. That number of protons plus number of neutrons equals the mass number, right? Well, this was our mass number. It was 39. Okay, so if I want to know the number of neutrons, and remember protons was 19, so I have 19 protons plus some unknown number of neutrons equals 39, well, that means I'm going to have to do some subtraction. All right, so my neutrons are going to be 39 minus 19, and that gives us 20 neutrons. Okay, so all we're doing is we're rounding this bottom number to a whole number, right? So instead of all of this, it's just 39. And we're going to subtract the top number, right? Always subtract the smallest number from the biggest number. We don't want a negative number here. Okay, you can't have negative particles. All right, so we have 20 neutrons in potassium. All right, so let's talk about electrons and where they go in the atom. We know that electrons belong in the electron cloud, and we saw on the activity that we did, the atom activity in Gizmo, that they fit into these circles. And we call these circles energy levels. Okay, so where do electrons go? They go into energy levels. You don't have to write this down yet. The first energy level is the one closest to the nucleus, and they get bigger as you go out. And an atom, the most energy levels they can have is 7. All right, so how many electrons specifically can go into each energy level? Well, in the activity we did, we only went up to the 3rd energy level and we didn't actually fill it. All right, so the first energy level can only hold 2 electrons. All right, so add that to your notes. The first energy level can hold 2 electrons. You don't have to draw this diagram, but you can if you want to. It's up to you. The second energy level can hold 8 electrons. So we saw this in our atom activity as well. The third energy level can actually hold 18 electrons. We didn't see that in the activity because we ran out of electrons before it was full. And finally, the fourth energy level can hold 32 electrons. All right, and so when you're adding electrons into the model of your atom, we have to fill up each energy level, moving from the inside to the outside. All right, and so now we're going to make a model of the potassium atom, and it looks like I have a typo in here. All right, this is actually supposed to say potassium. All right, so we already saw potassium has 19 protons, 20 neutrons, and 19 electrons. So how do we draw a model of that? Well, this is too much. It's too much to draw 19 protons and 20 neutrons. So what we do is we label it. So we're going to put the symbol for protons. We're going to say we have 19 of them in the center, right? So this is our nucleus in the middle. Draw the symbol for neutrons and say we have 20 of them. And then I'm going to show this is the nucleus by doing this. All right. Now we have to do 19 electrons in the electron cloud. This is where knowing how many electrons fit in the energy levels is important. All right. So we have 2 electrons in the first energy level. Then we have 8 that fits in the second energy level. So 1, 2, 3, 4, 5, 6, 7, 8. And so far we have 10 electrons, right? 8 plus 2 is 10. We need 9 more. So I'm going to draw 9 electrons on the third energy level. 1, 2, 3, 4, 5, 6, 7, 8. I'm again add 1 in there, 9. Okay, so now this is a neutral atom of potassium. All right, we're going to do lots of practice like this week, drawing Bohr models of different atoms during our synchronous meets. So I will see you guys later this week. Bye-bye.